Assalamualaikum warahmatullahi wabarakatuh and peace be upon you. My name is Tuan Rafidah binti Tuan Hassan, together with Siti Nurzaimah binti Muhammad Rashid and Muhammad Fazil bin Chitpa as authors. Today, I would like to make a presentation about production of concrete roofing tiles by using silica fume in partial replacement of cement. As for introductions, so as we know, nowadays building materials have undergone a lot of modification from ancient times until the transition to the present age of technology. Furthermore, in today's era of technologies, everyone wants an affordable and comfortable home. Therefore, every scientist and engineer work hard to develop and use new materials for the constructions of buildings that are definitely durable and cost-effective. It is generally known that building materials are composed of roofing sheet, block, concrete, clay, stone, sand, gravel, roofing tiles, steel, fine aggregate, coarse aggregate, and others. So besides, in the current construction of building, cement and concrete are vital components. So there are many environmental advantages of using concrete, including durability, longevity, heat storage, capability, and chemical inertia. However, cement is among the most energy-intensive materials used in the construction field and major contributor to carbon dioxide (CO2) in the atmosphere. Therefore, in order to reduce the environmental impact to the minimum possible, the quantity of concrete used in the building should be reduced. In addition, other alternative materials to produce concrete can be used, such as fly ash, and concrete should be used wisely. Let's proceed to the literature review. Generally, as is well known, cement and concrete are essential to the infrastructure of the modern world. There is no other material is able to fulfill the growing demand for building materials with such a low environmental footprint. Its widespread availability and low cost make cement by far and away the most used material on earth, with reinforced concrete accounting for more than half of all the manufactured materials and products. It is only because of these enormous volumes that overall the production of cement and concrete is estimated to account for around 5 to 8% of man-made CO2 emissions, which is called carbon dioxide. Moreover, this statement is also supported by Politeknik 2012, who stated that the cement industry is an energy-intensive and significant contributor to climate change. The major environment, health, and safety issues associated with cement production are emissions to air and energy use. Cement manufacturing requires huge amount of non-renewable resources like raw material and fossil fuels. It is estimated that 5 to 6% of all carbon dioxide greenhouse gases generated by human activities originates from cement productions. Besides, raw materials and energy consumption also results in emissions to air, which include dust and gases. The exhaust gases from a cement kiln contains are nitrogen oxides, carbon dioxide, water, oxygen, and small quantities of dust, chlorides, fluorides, sulfur dioxide, carbon monoxide, and still smaller quantities of organic compounds and heavy metals. Cement production has an important impact on carbon dioxide emissions and economic growth. The cement production is an important source of environmental pollution. The results of the studies also found that the USA and China have a global responsibility for cement production, determined as one of the central sources of carbon dioxide emissions. In a rapidly growing world, roof tiles are important components and to provide shield from rain and heat of the sun. So traditionally, more roof tiles are made from clay or slate. However, nowadays, roof tiles are also made of concrete materials. Mixes of concrete are come out from admixture of sand, cement, and water. But there are few disadvantages of the concrete roof tiles, such as the concrete tiles easy to break especially when the workers do the installation of concrete roof tiles at the construction sites. The use of cement also high in producing roof tiles, which can contribute in high costing in the construction work. Therefore, the most consumed human-made material, several byproducts such as fly ash, slag, and silica fume are effectively being used in the daily production of concrete as partial cement replacement to reduce CO2 emission. The use of silica fume decreases the permeability, thereby increasing the resistance of concrete against corrosion, improving its strength and durability. In addition, according to the Sobolev and Betrakov 2007, the use of silica fume will produce concrete with properties such as low heat of hydration, retarded alkali aggregate reaction, reduced freeze-thaw damage and water erosion, high strength, increased sulfate resistance, and reduced permeability. Let's proceed to the methodology. For this research, concrete roof tiles are made of mixture of sand, cement plus silica fume, and also water, which are molded under heat and high pressure. A mixed ratio that has been used in this research is 1.5 to 1, which is sand and also ordinary Portland cement, OPC. There are 72 samples that has been produced with 3 different ratios for silica fume, which is 5%, 10%, and also 15%. The testing was conducted in the manufacture of roof tiles that include surface quality, drying time, paint impact, strength, water absorption, water permeability, acoustic insulation, as well as thermal insulation. Okay, let's proceed to the results and discussions. Let's go to the first test, which is the surface quality test. Okay, table 1 here shows that the surface quality of the roof tiles that has been produced depends on the ratio of the use of silica fume. The increased amount of silica fumes in the roof tiles, the less smooth of the surface quality. This situation can be clearly shown as in table 1, where sample B has a very smooth surface compared to sample C and sample D. It may be due to the size of a particle of silica fume, which is larger than cement. Therefore, the more content of silica fume, the rougher of surface quality will be. Let's proceed to the second test, which is a drying time test. After 24 hours from making the roof tiles, the percentage of water in the roof tiles was measured by using protimeter to check the time required for drying roof tiles. All 3 roof tiles of each sample were measured to take the average of percentage of water. The average percentage of water was interpreted in the figure 1 as shown here. The result shows that the lowest percentage of water in the roof tiles is sample D, which is 15% of silica fume, with only 20% which still remains in the roof tiles after 24 hours. The highest reading of percentage of water in roof tiles is sample B, which is 5% of silica fume, with a percentage of 22%, which proves that the sample B took a long time to dry. Therefore, it can be concluded that roof tiles with silica fume took short time to dry. Let's go to the paint impact test. All the samples of the roof tiles were left for 24 hours at the racks. After 24 hours, the roof tiles were sprayed with paint and let it dry for 24 hours. The data was collected by observing the presence of fluorescence or not. Based on the observation from the table 2, there are no fluorescent presence on the entire sample. Let's proceed to the next test, which is a transverse breaking strength test. Okay, based on the figure as shown here, it shows that the strength of sample B with 5% of silica fume is the strongest among the 2 other samples. The strength of sample B is 948.77 Newton, which fulfills the Malaysian standard MS 797 for roof tiles because the value of strength test was exceeding 900 Newton after 24 hours. Sample C and D are not complied to the Malaysian standard. It is due to the large particles of the silica fume which less bond between each other that make the roof tiles less strong. The next test, which is the water absorption test. Based on the figure 3 here, it shows that the increases of the percentage of water absorption for the different ratio of silica fume. The highest percentage of water absorption is sample D with 15% of silica fume. The percentage of water absorption for sample D is 2.28%. Then it is followed by sample C with 10% of silica fume, which is 2.1%, and sample B with 5%. Okay, let's proceed to the next test, which is water absorption test. Based on the figure as shown here, the increases of percentage of water absorption for the different ratio of silica fume. The highest percentage of water absorption is sample D with 15% of silica fume. The percentage of water absorption for sample D is 2.28%. Then it is followed by sample C with 10% of silica fume, which is 2.1%, and sample B with 5% of silica fume, which is 1.23%. This circumstance shows that the lower content of silica fume in the roof tile, it will lower the water absorption of the roof tile. The properties of silica fume cannot substitute the function of the cement as binder because of the particles of silica fume is larger than cement. Therefore, the silica fume is suitable to mix with a mixture of cement roof tiles, but it must be in a low quantity. Next is the water permeability test. Based on the table 3 here, the 15% of silica fume, which is sample D, is not good for roof tiles because the permeability of roof tile is lower than the others. Sample B and sample C have a good permeability. The result shows that all samples are good on the permeability except for sample D. The water in the cup on the roof tiles at sample B and C is still remaining in a small quantity. However, the water for sample D is fully disappears. Therefore, a lower percentage of silica fume will make a larger quantity of water remains on the roof tiles. Okay, next is the acoustic insulation test. So based on the figure 4 here, the highest average reading for acoustic insulation in sample D, which is 15% of silica fume, which is 2.27 decibel. It is followed by sample C, which is 10% of silica fume, which is 2.10 decibel, and then sample B, which is 5% of silica fume, which is 1.63 decibel. The different reading between outer and inner surface showed the ability of roof tiles as sound insulator. The higher difference between outer and inner surface will lower the ability of the roof tiles to absorb sounds. Okay, let's proceed to the last test for this research, which is thermal insulation test. Based on figure 5, it shows that the increases reading of thermal insulation for different ratio of silica fume. The highest reading of thermal insulation is sample D, which is 15% of silica fume, with an average temperature of 2.17 degrees Celsius. Then it is followed by sample C, which is 10% of silica fume, with an average temperature of 1.83 degrees Celsius, and sample B, which is 5% of silica fume, with an average temperature of 1.8 degrees Celsius. The difference reading between outer and inner surface show that the roof tile does not absorb more heat. The higher difference between outer and inner surface will lower the ability of roof tiles to absorb heat. Let's proceed to the conclusion. The most significant result is when mixture of roof tiles with 5% of silica fume mix, as this proved to be the optimum percentage by the results. As obtained from testing, the result of surface quality of the roof tile is smooth. Other than that, the lower percentage of water in roof tiles after 24 hours. Roof tiles with silica fume does not take long time to dry. Besides, it can be directly painted after 24 hours without presence of fluorescence. The roof tiles with 5% of silica fume is almost succeeded because the strength is 948.77 Newton, which the highest result among other samples. The large amount of silica fume cannot replace cement in roof tiles. The result of water absorption with 5% of silica fume is 1.23%, where the standard of water absorption cannot more than 10%. Besides, the good result for water permeability is 5% of silica fume in roof tiles, since water does not pass through the roof tiles after 34 hours. However, the result of acoustic and thermal insulation with 5% of silica fume is less satisfied, with 1.63 decibel and 1.8 degrees Celsius. As a conclusion, silica fume cannot replace a cement in large quantities since it's less strong than cement, but it can be insulating sound and heat. Thank you for listening.